All right, everybody. I think we'll start our first in series of the webinars devoted to energy security issues and recent energy related issues that we see are relevant, especially to the state of Wyoming. And the School of Energy Resources is especially designed, and its mission is to provide energy economic security for the state of Wyoming. And so with that, we are opening our webinar series of this particular webinar that is related to the investigation of the energy crisis in Ukraine, my home country. And we invited several speakers from Ukraine, and also we invited a speaker from TerraPower to talk about nuclear energy. And so all of those issues will be raised today. So our main goal is to explore energy challenges and in the times of crisis and lessons learned from this crisis. Basically, we'll also talk about nuclear power and difference between water and natrium reactors. So we'll approach the building energy infrastructure, and also learn from Ukrainian energy infrastructure handling and the issues that Ukraine is going through because of the war and aggression from Russia. In addition to the disruption, the energy systems have been dramatically impacted throughout Europe, not just Ukraine. And so there are major concerns, not just for Ukraine and region, but the broader European region in general. So our first speaker today is Serhiy Averchenko. Serhiy is a Ukrainian politician. He's a former member of parliament and legislator of Ukraine. Since 2010, Serhiy has been the head of Chernihiv regional organization of the Udar political party. And since 2013, he has been the head of the State of Administration of Affairs. He was nominated in 206 electoral district in the October parliamentary elections. He's also a reserve lieutenant colonel. He has a bachelor's degree from Kurhan Military Political Aerospace Academy and master's from Chernihiv State Technological University. The format for Serhiy's talk will be that Serhiy will speak Ukrainian, and I will translate his passages as we go forward. Serhiy, to you.
Good morning, maybe good evening, everybody. I'm sorry, I will speak Ukrainian. Я хочу сказати, що до активної фази війни Україна затвердила енергетичну стратегію до 2050 року. І до цього часу було сплановано, щоб була у нас найбільше чиста енергетика, подолання енергетичної бідності, інноваційні технології, децентралізація системи енергопостачання і, звісно ж, виход на широкі ринки Європи і задоволення, в першу чергу, внутрішніх потреб у енергії.
So, from Serhiy, Ukraine, before the war started with Russia, Ukraine has compiled a new strategy, the new vision for energy security in Ukraine, and there were several agreements in place with the European Union, and different understanding that there is going to be exchange of energy between the energy grids of Ukraine and the European Union. Also, there were made promises about energy security in general, making sure that energy is abundant and ample and delivered to everyone in the country. Also, renewable energy became a new focus for the country, but without discontinuing other assets in Ukraine.
Хочу сказати, що оскільки Україна подала заявку на вступ на асоціацію до Євросоюзу, якраз в рамках і по нормах Європейського Союзу якраз відбувається, була прописана ця стратегія. Ну і, звісно ж, в рамках Паризької кліматичної угоди.
Well, this new strategy for energy security and sustainability in Ukraine was in correlation with the Paris Accord, and also because of the motivation of Ukraine to join European Union.
Головними цілями було поставлено це кліматична нейтральність, тобто екологічна складова, потім скорочення повністю вугілля в енергетичному секторі, модернізація інфраструктури, використання ресурсів, більш ефективне використання, поставлено було на порядок коефіцієнт корисної дії, і всебічна інтеграція в ринки, я ще раз повторюсь, Європейського Союзу. Ну і, звісно, забезпечення внутрішніх ринків.
Well, the main goals of this strategy before the war were to answer the European markets and to make sure that there is climate neutrality that could be achieved, discontinuing some of the coal resources, but more importantly, resource sustainability and increase in renewable energy supply and market integration. That was the main strategy for the new Ukrainian energy.
У нас 6 березня 2022 року відбулася ключова подія в українській енергетиці. Тобто національна енергетична система об'єдналась з європейською мережею. І таким чином так сталося, що за 4 години після того, як Російська Федерація почала війну з нами, українська енергетична система повністю відключилась від Білорусі і від Росії.
Due to a coincidence, right after Russia started the invasion on Ukraine, almost at the same time, Ukrainian energy grid discontinued from former connection with the Russian and Belarusian grids and became connected to European Union. Of course, it is a pure coincidence that these two happen in terms of the timing, but maybe not in terms of the political structures and long-term agreements.
Тобто на енергетичній карті Україна вже стала Європейського Союзу, стала членом Європейського Союзу. І вже 30 червня 2022 року під час війни почався перший експорт електроенергії з України до Європи. А через місяць, уже 30 липня, цей експорт зріс в 2,5 рази.
So again, one can say that Ukraine has joined the European Union right before the war has started. Maybe not if as a full-scale European member, but as an energy supplier, and so we started supplying, and Ukraine started supplying energy in almost immediately after the war has started, but then doubled the energy supply in about 3 months from the start.
Так, наприклад, ми в Румунію та Словаччину постачали по 125 мегаватт. У Польщу 210. 200 МВт постачали, експортували в Молдову.
So to name a few numbers on how much energy was supplied to different countries. Romania and Slovakia has received 125 megawatts in those first couple months. And Poland received about 200 megawatts, and Moldova has received about 200 megawatts as well.
Але 11 жовтня 2022 року Україна цей експорт зупинився, тому що за день до цього, 10 жовтня, Росія нанесла жорсткий удар, ракетно-бомбовий удар по інфраструктурі нашої країни і порушила дуже багато і енергетичних об'єктів, і тому нам навіть для власних потреб вже енергії не вистачало. Тут вже не було питання про те, щоб експортувати їх за кордон.
However, because of the strikes prior to the 10th of October of previous year, Ukraine had to stop energy exports and had to mend their own infrastructure and supply their own needs.
Справа в тому, що нам взагалі прогнозували, що ми тут за 3 дні взагалі вся система розвалиться, але ми протримались 21 день, ну, як у нас кажуть, розрулили цю ситуацію. І це говорить про те, що говорить про стійкість енергетичної системи України і керованість. Якщо в деяких країнах є проблеми там з цим, то Україна може якось поділитися власним досвідом з цього приводу.
So the forecast for Ukraine is that it's not going to last more than 30 days until the energy infrastructure will crumble. However, still Ukraine stands, and there are lots of lessons learned from how to manage the infrastructure in a time of crisis, and how to do this how to distribute the energy safely and securely in unprecedented conditions.
Так, наприклад, Росія і зараз намагається атакувати об'єкти енергетичної інфраструктури. На теперішній день у нас понад 50% теплової генерації зруйновано, 30% сонячної і майже вся, тобто 90% вітрової генерації. Зупинено низку державних шахт. Окупована Запорізька атомна електростанція. Підірвана Каховська гідроелектростанція. Розграбована повністю Чорнобильська атомна електростанція.
So at the same time, the situation is there. There are a lot of assets that cease to exist. About 50% of coal power plants are no longer in operation. About 30% of sun-generated electricity is no longer here. About 90% of wind-generated capacity is out. There are also mines that are not operational because of the war. There are also nuclear power plants like Chernobyl, and at the moment Zaporizhzhia nuclear power stations are not in the best condition, and also the Kakhov hydroelectric station is not functional, obviously, because of the attack.
Якщо ви звернули увагу, та вітрова генерація практично повністю зруйнована або відключена, тому що вона була в Криму або на узбережжі Чорного і Азовського морів. А зараз це Ну, на сьогоднішній день поки що це окупована територія, і брати тут щось зруйновано, а щось працює, але працює не на Україну.
Important to note that wind generating capacity is out because most of those assets were located near shore or offshore of Ukraine, and with the Russian aggression, most of those assets either destroyed or are working to not on Ukrainian not for the energy security of Ukraine.
І проблема зараз в тому, що навіть ті об'єкти, які знаходяться на неокупованій території, ми не в змозі їх якісно відремонтувати, тому що постійно є загроза прильоту ракет, і вони ціляться в основному на об'єкти енергетичної інфраструктури.
And the problem also that the Ukrainian grid is undergoing, and assets that are already are not operational are nearly impossible to fix because after being fixed they become inoperational again because of the strategic strikes from the Russian side, and so it becomes a kind of race on how to redistribute those resources, and moving forward will be tricky because preservation of the assets becomes difficult because most of the strategic strikes with the rockets from Russian side are directed at energy infrastructure.
Великі об'єкти, які потребують багато енергетики, ми намагаємось підключати до мереж, до загальних мереж, а маленькі об'єкти, маленькі потреби покриваємо за рахунок генераторів. І ми дуже вдячні країнам Європи, практично всі країни Європи, за виключенням деяких, допомогли в цьому плані. Зараз є достатня кількість переносних, перевозних генераторів, які закривають проблеми енергопостачання у школах, у садочках, де неможливо провести стаціонарні лінії електропередач.
And Ukrainians are very thankful for all of the things that European countries are doing in terms of helping with the energy balancing the grid, because the large assets are impossible to reallocate, so we need additional supply. And on the small side, on the residential side, there are needs that are covered with the electric generators that are coming and supplied by a lot of European countries or United States.
Зараз, але все рівно ми віримо, ми впевнені, що буде наша перемога, і тому уряд України планує залучити в відновлення енергетики десь порядку 120 мільярдів доларів на ці всі потреби. І ми плануємо, звісно, хочеться зменшити кількість ядерної енергетики, але в найближчому майбутньому це зробити, ми розуміємо, нереально. Тому що буде відновлення країни, буде велика потреба, а гідроенергетика цю ситуацію не витягне, і теплова енергетика теж. Тим паче, що у нас зараз і шахти зруйновані вугільні, і газові проблеми є з постачанням газу. Тобто ситуація на цьому ринку дуже складна.
In current conditions, there is a lot of hope for rebuilding the infrastructure. So currently there is about 120 billion set aside to fix energy objects in the upcoming months, and hopefully there is going to be a resolution of the war that is very favorable for Ukraine. There's a lot of hope for that. At the same time, we understand that there are a lot of challenges. Most of those challenges are associated with the infrastructure that was decimated by Russian aggression, and so Ukraine is out of options for coal energy because the mines are not functioning, and natural gas infrastructure is also not in a good shape, so it will take some time to develop. The wind wind resources will not cut it, or solar will not be sufficient to fulfill all the energy needs. And so in current conditions, it seems that nuclear energy will be one of the primary goals for Ukraine to recover. Otherwise, because of the country will rebuild eventually, and a lot of capacity energy delivery will be necessary. So energy storage and the nuclear energy probably will become the focus for the future.
Але все рівно уряд України ставить завдання залучення потужних інвесторів, і, звісно ж, всі преференції, найбільші преференції будуть надані на зелену енергетику, на виробництво водню, виробництво біопалива, на ті ж гідроенергетику. І зараз буде стояти питання про відновлення Каховської ГЕС, греблі і встановлення нових уже сучасних потужних генераторів, які б виробляли велику кількість електроенергії і не шкодили зовнішньому середовищу.
However, on the long term, Ukraine is looking to decarbonize the grid, making sure that more renewable assets are going to be online, and also looking forward to rebuilding and enhancing hydropower capacity. Also very interested in building hydrogen generation, biofuel generation, to make sure that the long-term outlook and the energy security is there for Ukraine.
І в кінці свого повідомлення хочу сказати, що всі зацікавлені сторони, інвестори вже можуть готувати проєкти, подавати пропозиції. Наш уряд відкритий для того, щоб відновлювати енергетичну систему України і працювати разом з Європейським Союзом, і Сполученими Штатами Америки, і з Великою Британією, з Канадою, і всіми іншими друзями для отримання кращих технологій від цих країн. І ми можемо поділитися власним досвідом, як ми керуємо нашою системою, і навіть в такий важкий момент нашого життя ми не зламалися, і наша енергетична система встояла. Значить, наш досвід заслуговує на увагу. Ми бажаємо всім щастя і мирного неба над головою.
Well, in conclusion, Serhiy wants to say that Ukraine is very open to all of the possible investment coming from the European Union and United States and other countries, but also it's not only that Ukraine is looking forward to rebuilding a new infrastructure that is more advanced, hopefully a lot more advanced technologically, more sustainable, more secure. But also Ukraine is open to exchange for the exchange of the experience that it had in this war, and there is a lot to share on how to balance the grid and how to make sure that the grid is operational in unprecedented circumstances. With that, Serhiy wants to conclude his talk and wishes everyone peace and health, and going forward into the future with a positive outlook.
Good luck.
Thank you, Serhiy. Well, we'll not answer questions at the moment. So we will go to our next speaker, who's Eric Williams. Eric Williams is a Senior Vice President and Design Authority at TerraPower. In this role, he oversees the engineering associated with the TerraPower's advanced reactors and the medical isotope programs. He works closely with the senior program managers to provide design analysis and testing to meet the project objectives. Williams has 22 years of experience in engineering and has spent the last 15 years developing nuclear power plant design with an emphasis on safety. With that, welcome, Eric.
Thank you, Eugene, and thank you very much for your comments, Serhii. Very interesting, and we appreciate the situation you're in, and wish you a brighter future and coming up. So, as Eugene said, my name is Eric Williams, and I'm working on the Natrium nuclear power plant. This is an advanced nuclear reactor, and you know, I get the privilege of talking to you a little bit about the technology today. And I'm going to be focusing mostly on the differences between this reactor design and currently existing what we call light water reactor technology. So I'm going to be kind of focusing on those things. I'm not going into great depth into the technology, but if you have any questions on anything, we can certainly take them in the question period. So right now, TerraPower is currently working on this project, and we have about 1,000 people now working on the project. So we've been ramping up and growing our staff to take on this challenge, and we're all very excited to be working on this and interacting with the community in Kemmerer, Wyoming, as we start to bring our construction permit application to the Nuclear Regulatory Commission for approval coming up in the next year or so. So we're getting really close to that, and so it's kind of an exciting time for us right now in the project. So I'm going to begin by just talking a little bit about what the Natrium nuclear power plant is, and then we're going to get into a little bit more detail in the next couple of slides. So we call this a sodium fast reactor, and so instead of being cooled by water, it is cooled by a liquid metal. This is sodium in liquid metal state. And so this is a very excellent coolant for nuclear power plants, and it's been around since the earliest days of nuclear power in the United States. Some of the very first reactors to produce electricity were actually cooled by sodium. So it's something that we do know a lot about and have run these types of plants before under the Department of Energy programs here in the United States, and they've had reactors run worldwide as well. So there's some things that are different about this power plant, and I'm going to be illustrating this a little bit on this slide with a picture. This is not how the plant actually looks on the site, but it helps us understand what is going on. And so essentially the Natrium plant was designed in mind with an electricity grid that is growing in terms of the amount of renewable energy coming online. So intermittent electricity sources from wind and solar, you know, are growing and growing, and it's well known that once a grid, becomes saturated with renewable energy, it needs a lot of fixed, reliable assets that are not intermittent to work along with it to add stability to the grid and reliability to the grid. And so Natrium was designed with that in mind. And so what you see there at the bottom of the picture is a nuclear reactor. This is generating heat that is sent to an area of the plant where we store it as thermal energy in these two large storage tanks that are storing the heat in the form of liquid molten salt. And so the energy is constantly being stored, very similar to the way your hot water heater in your house, stores hot water for you to use at various times during the day. We're going to store the energy in this part of the plant we call the energy island. And then we're going to use that to send electricity to the grid. And so at a steady state level, we can continue to provide about 345 megawatts electric constantly to the electricity grid. But when we need a little bit more electricity, we can actually draw from that storage and produce electricity at 500 megawatts electric, about twice a day for periods of about 5.5 hours. If needed, if there's a lot of renewable energy available on the grid and the wind turbines are spinning and the sun is shining, we can actually dial it back down to 100 megawatts electric if needed as well, and just continue to store the excess energy in these tanks. And so the ability to do this comes from the fact that we're using this liquid metal as a coolant, because we can achieve much higher temperatures coming out of the nuclear part of the plant. And that enables us to store the energy. So at lower temperatures, you wouldn't be able to store energy efficiently. And so you couldn't provide this extra feature to the electricity grid to provide this load following capability. So those are, the main features of the Natrium plant as a product. And it gives you a number of the benefits that you can kind of see listed here on the slide. It kind of reduces a lot of the extra nuclear systems that we sometimes call nuclear sprawl, that lead to some of the high costs of nuclear plants historically. This allows us to really focus on a compact safety case for the nuclear part of the plant and keep that totally separate from this other part where we're storing the energy and we're producing the electricity. And so there's this concept we call a decoupled approach that takes a separation between the nuclear part of the plant and the energy island part of the plant. And so it just leads to a much simpler design and the ability to construct it more rapidly. It's also important to point out a higher thermal efficiency that's achieved here, also because of the higher temperature that's allowed by using the liquid metal coolant. So that was just a basic introduction to the concept. And then this just gives you a little picture of what the plant would look like as it's laid out on a site, like the site in Wyoming. And so at the bottom of your slide there, you see the nuclear island. And this is the part of the plant that's just generating heat, every day, constantly at 100% power. And that heat is being sent through this salt piping over to the energy island part of the plant, where you see those two large storage tanks. And so these two parts of the plant can operate independently from one another. So the nuclear island section can keep generating heat, and the energy island section can be operated as needed to control electricity delivery to the grid. And if there's ever a situation like an abnormal operating condition and the plant needs to, reduce power and address an issue, it can totally decouple itself from the energy island part of the plant and just go into a low power operating condition and go look into whatever the situation might be. The other thing that I'm going to start getting into more on this next slide here is the safety of the plant. We've taken a big leap forward in terms of safety with this advanced design, and I'm going to talk a little bit about that. But on this slide, I wanted you to appreciate that all of the structures that you see on the site here, none of them are required for safety. So all of the systems required for safety in this plant are going to be underground, underneath the reactor building and the reactor auxiliary building on the nuclear island section of the layout there. So my last slide here is just to go into more detail on what is different from light water reactor technology, such as the Zaporizhzhia plants in the Ukraine. Those are what we call pressurized water reactors. And so we have a sodium fast reactor here, so I'll point out the key differences. And the four characteristics that I have up there at the top are really the main ones to focus on. So we have an advanced fuel design. So this is an advanced design that we've been developing here in the United States for a couple of decades now, actually. It was put aside back in the 1980s, and now TerraPower has kind of picked it back up and taken a few more advances in the technology so that we can use fuel more efficiently in the reactor, and we can actually extract more megawatts electric per kilogram of uranium coming into the reactor. So it's a much more efficient fuel type, and it's also got a lot of advanced features that make it more safe because it's made purely out of metal. So it's made from a uranium alloy. It's a metallic fuel, and metals are able to keep themselves cool more efficiently. So that adds a lot of safety properties to the fuel design. And then in addition to that, the coolant that we have inside the reactor vessel that you can see on the right there is actually a metal as well, sodium metal in the liquid state. And so there's a strong compatibility between the two. The fuel is metal, the coolant is metal, the vessel surrounding it is all metal. So there's a very efficient pathway for heat to get out of the reactor and just be cooled by air flowing around the outside of this vessel that you see on the slide here. So that's the key safety philosophy, is to just allow everything to be cooled by air instead of having to bring sources of water in and constantly keep bringing more water in to keep the plant cool. It's also a pool type reactor. So this vessel you see here is full of coolant that allows for heat to be stored in there whenever there's an abnormal event. And then we have the thermal energy storage that I was talking about on the prior slides that allow us to work on a grid with a high amount of renewable energy. And so if you put all of this together, you get a very simplified response whenever there's any kind of an abnormality in the operation of the plant. We have this ability to keep the reactor cool indefinitely, just using air surrounding the reactor vessel. There's also a low pressure containment, and all of the systems in the plant are at low pressure. So that's one of the big differences with water. In order for water to remain a liquid at a high temperature, it has to be pressurized. And so all of the light water reactor plants are under high pressure. And when there's any kind of a break in a system, all of the inventory of the coolant wants to go out and turn into steam, which causes the challenges to the safety systems. So in this reactor, everything's at atmospheric pressure because liquid metal can be at a high temperature at just normal atmospheric pressure. So it allows us to get the cost down of all the systems, and it leads to a much safer plant. And then finally, with this amount of safety, we don't have to rely on the operators actually doing anything to keep the plant safe. So it can all be cooled automatically. It kind of has a self-correcting capability to it, where it wants to reduce power if there's ever kind of an increase in temperature inside the reactor core. And we also don't have to rely on any electric power systems. So when we lose large areas of infrastructure around the nuclear plant, such as in a war zone or anything like that, we're not reliant on that electricity grid to provide power to run safety systems. We have the ability to cool just by natural, gravity and forces of nature that keep the plant cool. So that's one of the great features here. And then architecturally, all of those radiological systems are underground, like I was talking about on the prior slide. And then in terms of planning for emergencies, if there were ever any accident on the plant, the plan is to keep all of the radioactive, if there are any radioactive releases, they're maintained within the site boundary of the plant. So that reduces the ability to affect, the population around the plant with evacuations and things like that. So those are the main features that I wanted to let everybody know about that are kind of driving us to use this advanced technology. And, I've been working on these reactors since prior to the Fukushima Daiichi accident. And, I keep, it excites me to keep developing the technology forward, because whenever we live through a situation like Fukushima, or even like what's happening in the Ukraine, it reminds us of the need for these extra safety features and extra robustness and resilience for our electrical power system. So thank you very much for letting me share with you some of these thoughts. And I'll turn it back over to you now, Eugene.
Thank you very much, Eric. Again, no questions at the moment, but we'll address them a little bit later. It is my pleasure to present to you Amiran Kurtaladze and Anna Dubina. Amiran is a chief specialist and project manager at Synergia, a company that specializes in design, construction, and installation work of power generation. Amiran also worked as a project manager and in design, in construction, installation works in the field of mobile communication and power generation industry for over 20 years. Amiran has a master's in mechanical engineering in rocket propulsion from Dnipropetrovsk State University from 1988, and he also graduated from the military department at the university and received the rank of lieutenant. Anna Dubina is a senior technical sales manager at Interpipe. And Anna will be presenting for Amiran, but if you have any specific questions for Amiran, be happy to answer. So Anna Dumina is a senior technical sales manager on Interpipe for over 9 years at the moment. And Interpipe is a global producer of steel pipes for all major fields of application, including oil and gas, transportation, power generation, mechanical, and structural use. She will also work as a design engineer at Promic Ltd, which is another company that specialized in structural design of metal and concrete structures. She has a master's and bachelor from Pridniprovsk State Academy in civil engineering and architecture. So to you, Anna.
Hi, everyone. I will share my screen right now to show you the presentations that I would like to make. Do you see my screen?
Yes.
Okay. So as Eugene have said, I am here to help Amiran to make a presentation of a company Synergy that works since 2006. And this is quite a big company. This is a group of company that involved in all stages of design, construction, and commissioning and maintenance of different objects of an energetical system in Ukraine. So briefly about this company. This company have been working from 17 years on the energetical market in Ukraine, and there is a lot of difficult and different interesting solutions that they have implemented on this field. More than 150 projects for overhead lines, substations, and other energetical objects. The main of this company is that they have the closed cycle, so they have their own design engineers, they have own construction staff, and a very big fleet of equipment and special purpose machinery. It's about 100 and more units that they use for construction, so they do not need to make any to get anything from aboard. So here we have some photos of overhead lines. So as you can see, the Synergy has a lot of experience in working with graded overhead lines that can be placed in the fields, and also with multi-sided steel poles that can be used for restricted areas in the cities. Also, Synergy is great in cable lines installation, difficult trenches installation, cable lines, and transformational substations. They make these projects for up to 330 kilovolts. Also, as our first speaker, Serhiy Averchenko have told, before the war, and we hope that after the war, a lot of attention Ukraine paid to solar and wind energy, and we try to get more and more projects that will be involved in this green energetical grid, let's say like that. But unfortunately, a lot of these projects are under occupation right now. However, after we win, after Ukraine win, we will for sure gain more. Because we will renew all that all these objects. So let's talk briefly about the current situation that we have right now. As you maybe know, that the hardest situation for energetical system in Ukraine were started on the fall last year in November. In November, we had I think, a month when every day was shutting the missile attacks on energetical objects, because there was the aim of this was to make the total blackout in Ukraine. And according to some officials, up to 40% of the country's energy system was destroyed. So I would rather comment in here. So sometimes in different parts of the country were destroyed the generation part, but the transportation part was good. In the other part of country, the overhead lines were destroyed, but the generators were good. So this, and also the thing that in ex-Soviet Union, all the constructions that were aimed to produce or to transport the energy were the objects of very high importance. So all these objects, they had the safety margin. So due first for this, and the second due for the great decisions that were made by our government, we didn't have the total blackout. Here you can see an example how we had the weekly shutdown schedule. As you can see, we had, and this is like the good one. So in this schedule, we had like 6 hours we have the light, 4 hours we don't, then 5 hours we have the light, then 4 hours we don't. But unfortunately, after shutting, there were 2-3 days when my home city is a million plus people city, Dnipro. It was partially without the electricity at all for 2 or 3 days, and it was rather cold. However, we survived that, and right now we can say that we don't use at all this shutdown schedule, because we didn't have to. And the other situation that really influenced the energy system in Ukraine and really is terrifying, this is the situation that occurred on the 6th of June, when the Russian terrorist blew up the Kakhovska hydro plant. As you can see on this photo on the left, the dam was destructed at all, completely destructed. So first it was saying that it was just the 6 from 28 parts destructed, but right now they can tell that it's almost all are destructed, and it cannot be rebuilt or reconstructed. It should be done something other. I don't know. So the main, the worst part of this is that the water from this Kakhovsky plant, it was cut off, and the reservoirs that we have on Zaporizhia nuclear plant that is under occupation since the first day of Russian invasion, it cannot be refilled right now, because it was refilled using the water from this Kakhovska Sea, we are saying like that. So right now, the government is saying that the situation on the Zaporizhia nuclear plant is stable, and the cooling ponds are currently filled. And the other information is that they shut it down on the May, all the 6 power units on this nuclear plant. And right now they are supposing, they're hoping that the system will work sometime in the closed cycle. So it should not have to take the water from the others sources, it just will be cooled by itself using the water inside the system. However, this pond, how it say, Evgeny, help me please, бассейн охладительный.
Cooling reservoir.
Okay, thank you. This cooling reservoir is open, and in the area of Zaporizhia nuclear power plant, the summer is really, really hot. So this is also the point of risk when the water just will, like in the nature way, go through the vaporized, and it's all. So nobody can predict correctly what we will face in this summer. However, we will hope for best. Here you can see the diagram of the level of the use of reservoir water level mark. Right now it is before the dam destruction, it was almost 17 meters. The normal level is 18 meters, or 16, I'm sorry, 16. Right now we're talking about, I think that we are here. It's not 14, but less than 14.5. So as you can see that 16, this is a normal level, 14.5, that this is the problem that we face right now, that the agricultural sector is very struggling about this because they have no water to fill for fields, and they can lose a lot of wheat that should be transported to Africa and other countries. If we will go down with the level of water, we will face worse and worse problems, and 2,000 plus people don't have some drinking water, and if the level of water will be lower than 13.2, it can cause these problems that we were talking on my previous slide with the cooling of nuclear station in Zaporizhia. But I hope that everything will be done in the best way. And you know that some people from EIFA are there on Zaporizhia nuclear plant. They're watching the situation, so we will hope we will do this better. So before the war, the total generating capacity that all the Ukrainian power system had, it was 38 gigawatt. The 51% of this was generated by nuclear power plants. As you may see on the map on the right, in Ukraine we had 5, but right now we have 4 operating nuclear power plants. The one that in Zaporizhia is occupied right now, and the Chernobyl, was destructed in 1986. As during the blackout, we had the opportunity to see that the renewable energy sources are very unstable. We would propose to go with next conclusions, how to deal with the energetical crisis in Ukraine after the war. We would propose to produce in total at least 30–50% more than consumers' needs. 30–40% of generation should be provided by nuclear plants. By other plants, and the main part of energy should be provided by nuclear plants, because this is the stable source of energy. Then if we will talk about coal-fired power station, it should be replaced for sure, because we will going to face a lot of environmental problems about the pollution that is caused by destruction of the dam. And if we can reduce the other sources, we should do that. So for the first one, we can change the coal-fired power stations to more more friendly to nature. Then we would suggest to have networks that might be a double supply of capacity and completely re-knit inside the Ukraine, because a lot of problems that we have during the blackout was because the system inside Ukraine is not cycled, is not triggered, it's interrupted. So we have to close this circle inside the country. Also, we have to get the accumulator stations, the energy banks that will help us to get some power to low the peaks of energy if they occur, so some accidents or something. And for sure to integrate Ukraine to European system. So after that, this scheme will allow us to operate this plant safely, because if the nuclear plant is operating in the stable way, it is rather safe. To operate the renewable green energy facilities in the good mode, and to have bank storages with this accumulated energy. Then we will have the opportunity to exclude from operation all carbon taken and or all carbon fuel station, which are very bad for environment. And as Evgeny said, we had the plan for 2050 to get to be very, very environmental friendly country. So and to, like I said before, to be conducted to European energy system. So this is all. Thank you for your attention.
Thank you, Anya.
Thank you very much, everyone, all the panelists today. We ran a little bit over time, but I think we should allow time for questions, so we'll kind of extend the webinar a little bit longer. And I will go over the questions that were sent to us prior to the webinar. And the first question is, should governments attach extra social or military costs or value to a grid with a small number of big generators, like a gigawatt scale nuclear, or a large number of small generators like a megawatt scale wind diesel generators? If so, how should industry be punished or rewarded for where they fit in that continuum? Does anyone want to answer this, the first question? Maybe Eric, someone else?
Yeah, I can try it out. So I do think you know, that nuclear power plants are very robust sources of electricity, and they can be used strategically in places where, you know, assets have a high amount of, you know, significance for national security, or to maintain human health and security and areas like that. And so, and I've had a chance to work on a few projects that had those extra elements to them. And I think that we should assign greater value for those and use nuclear power plants in those applications, because, you know, our most fragile, at least in the US, and I think in many areas of the world, the most fragile part of the electricity grid is the grid itself. And being able to get the electricity to where it's needed But nuclear power plants are pretty robust. They're built to withstand, impacts from large commercial aircraft, and a wide array of external events and natural disasters. And so using them in places where the power needs to be really reliable is, I think, a key asset to it. As far as being punished and rewarded, I'm not exactly sure how to answer that part of it. I think, incentivize is the word I would use. I think there's a strong incentive to do that where it makes sense. And I do think that does take some government strategy and being involved in the process of the design of the power plant up front. And so I do think where those benefits exist, the government should kind of be involved in setting up, involved in the design of the power plant and how it is designed to work on a particular site.
Thank you, Eric. The next question that is directed to you as well. What is the difference between the reactor TerraPower is developing in Kemmerer and the SMR that is being developed in NuScale in Idaho? The NuScale project has already received approval from Nuclear Regulatory Commission. How and where is TerraPower in that process? And this is from Travis Samulski.
Okay, great. Thank you for the question, Travis. So, all the differences that I mentioned in my presentation would exist because the NuScale design is light water reactor technology. It's a pressurized water reactor. So it has the same properties of, having to keep water at very high pressures in order to keep it in the liquid state, and being able to provide constant cooling to the core once it's in a shutdown condition. And so it has those same properties, but what the NuScale technology has done and done really well is that it's really optimized what the light water reactor technology can do by adding a large degree of passive safety and a unique architecture that allows for the benefits of modularization, which really help with areas like cost reduction. And then what the Natrium reactor has done by those features I talked about, using liquid metal coolant and metal fuel, is they've taken safety kind of to the next level, where we don't call it passive safety, we call it inherent safety, because everything required for the safety is already in the reactor. It's already there. Nothing additional has to be provided. And the ability to remove heat indefinitely using air as your ultimate heat sink is kind of taking it to the next level. So that, plus the higher temperature output of an advanced reactor like Natrium and others, allows for that energy storage to play a role, which isn't possible with light water reactor technology. Well, it's just not economical with light water reactor technology. And then as far as where they are in the licensing phase, you're right, the NuScale design is well ahead of us. They've had their design approved by the Nuclear Regulatory Commission. In the Natrium case, we're currently working on a different licensing framework than what the NuScale reactor did, because we have this unique architecture where we're able to start construction on the energy island before we start construction on the nuclear island. Our goal is to get to construction as fast as possible. So we're using what's called a Part 50 licensing process, which is slightly different. And we're still in the pre-application phase. So we're getting ready to submit our application next year for the construction permit. And then it's another couple of years to get approval. But in the meantime, we can start construction on the non-nuclear part of the plant. So that's one of the benefits we have. And we chose that so that we could get to construction quicker. And so that's roughly where we're at in terms of the licensing process.
Thank you, Eric. I think the next one is directed to Anna, and she answered already this question, but maybe there's something to add. Maybe Serhiy wants to add as well. What are the realities around the Kakhovka dam break, and has it impacted or will impact the Zaporizhzhia nuclear plant? Is there anything else to add to what Anna already said?
I would just add that according to specialists that are monitoring the situation every day, right now we have nothing to fear, because right now the nuclear plant is in the idle mode. So the level of water is in the cooling pond is enough. And we can just hope that Russians are not so crazy as they want to, as they want us to think about them, because the one thing is to destruct the dam, and the other thing is destruct the nuclear plant. So we hope that we will not face this problem.
Thank you, Anna. I think next one is to Eric. How close is the US or China or other countries to getting a liquid fluoride thorium reactor working?
Oh boy, yeah. I have to say I'm not an expert on liquid fluoride thorium reactors, but it's somewhat similar to another design that TerraPower is working on called the molten chloride fast reactor. And the similarity is that both reactor types would use a liquid fuel as opposed to a solid fuel, which is a very advanced form of reactor design that a number of people are working on. And I think these designs are still quite a ways away from being commercialized. I think they pull a lot of their knowledge, experience from the molten salt reactor experiment that was done at the Oak Ridge National Lab here in the United States. And I think a number of companies in China and the US are working on these designs. I think in the US, the company Flybe, I think seems to be the one doing most of the work. And when I just read the news on progress being made, it looks like they're still in the conceptual design phase. So maybe I would say 10 to 15 years away from being operational. And of course, if somebody, I think a lot of additional investment is needed to take these designs and, get them to the commercial stage. And if somebody wanted to really go after them, I think that time could be shortened. One of the advantages of having liquid fuel is that you really have opportunities to shorten the qualification time for the fuel. So that's one of the reasons that people really like these designs. But my opinion is, probably 10 to 15 years minimum for that technology.
Thank you again. Well, how safe are nuclear power plants? And it goes to Eric, but also maybe Anna and Serhiy and Amiran as well.
Well, I could start. Yeah, I get this question a lot, actually, and certainly with what is going on in the Ukraine, it's certainly a reminder of all the aspects of safety that we take very seriously in the nuclear industry. And I do think that existing nuclear power plants are extremely safe and have an excellent safety record. We've made some technology improvements that I think make that even better and lower the cost of achieving that level of safety. So that's great. But the existing plants have a tremendous safety record. And there's been a lot of work recently in terms of quantifying it in terms of the loss of human life per unit of electricity that we generate in our society. And the numbers that I've seen on that are pretty staggering. Like I think coal and oil are the highest in terms of loss of life due to the effects of both industrial accidents as well as pollution and its effect on human health. The numbers are tremendous. And then, an order of magnitude lower than that come natural gas and hydroelectric power, but both of those still have meaningful loss of life per unit of electricity over, global data. And then the lowest of all is nuclear power as well as wind and solar. And when you get down to looking at loss of life there, it's in the very, very low numbers across all of the data that we have. And so I think, nuclear and renewable energy are together the safest form of electricity that we have.
Thank you. Maybe Anna will add something.
No, everything is great. Thank you, Eric.
How do you see the future of energy sector in Ukraine, and how will that affect the global economy And this is to Serhiy, to Anna.
I answered already this question in my presentation, but to sum up, we have to make a full integration with the European energy system, and this will provide both of this system, European and Ukrainian, the stability and reliability, and we will have an opportunity to transfer capacities quickly if we need to. And this will for sure have the positive effect to European economy and to Ukrainian economy. And as Europe is a part of world economy, so it will influence positively to the world economy. So this is my opinion.
Я думаю, що треба, наше головне завдання – це перемогти в цій війні, і все в нас буде, все в нас швидко відбудується, все буде нормально, але треба нам допомогти, щоб країни, Сполучені Штати, в першу чергу, і країни Європи мають допомагати нам у відновленні України.
So the message from Serhiy is that he has a very positive outlook on the future and the integration into European Union, both grid and system. But first, the victory is necessary, and then the second, the help will be necessary to integrate from both the European Union partners and from United States as well. Thank you. So what can countries do to prepare for any potential future energy crises? Anyone to take this one?
Well, I think for me, I think we need to work on grid resilience. I do think that is such a fragile part of our infrastructure in general. And so, you know, it kind of gets back to the very first question someone asked about strategic assets. I think we need to look at that and work on making our grid stable and reliable, and protect those assets as much as possible. And, you know, with climate change, you know, facing the threat of more dangerous climate events that we have to deal with, I think we need to also look at that in terms of new designs for nuclear power, which will be increasingly relied upon more for reliability, I think, in the future. So I think paying more attention to that is warranted.
Thank you very much for all of the panelists today. I think it was a very wonderful session. We'll plan the next session, and we'll tell you about the next session, upcoming session, in the email or at our website or LinkedIn pages. Thank you for all the attendees as well, and we'll adjourn. Thank you very much.
Thank you. Have a nice day.
Thank you. Bye.